This is the fourth of a video series dedicated to ResearchMaps. This video will be focused on an app that facilitates the generation of research maps. My name is Alcino Silva and I'm a professor at UCLA Medical School. Let me start by saying that although the app I'm about to introduce is very useful, you can derive your own research maps with nothing more than pen and paper. And this is actually an example that I photographed out of one of my notebooks. The advantage of the app is that it allows you to accumulate and integrate and easily share the data and maps of many papers. Most importantly, the app allows you to deal with information in the maps dynamically. Based on the information that you and others have entered, you can choose to draw maps of just the information you need. This really is the key to using any map. What is it like to use the app? Take, for instance, the paper on the left. The user identifies the experiments in that paper, and then these experiments are entered into the app. The app then creates a relational database with each of the experiments entered. The next step is for the app to use graphic routines to graph the data entered. Importantly, the user determines which data is to be graphed. The first step for a new user is to request an account. Returning users will simply enter their email and password. To start an entry, the user needs to tell the app about the entry. Most entries will use a research paper already in the Library of Medicine. With a few keywords provided by the user, the app can query PubMed and automatically import the author's publication information, PubMed ID, and abstract of a paper of interest. The experiments entered will then be linked not only to the user's account, but also to this specific paper in the relational database established in the app. Alternatively, the user can enter information that will serve to identify the experiments to be entered. Only experiments associated with information about a paper imported from PubMed will be shared with other users. As you can see, this page includes a slot to enter the ID of an agent, the phenomenon that's manipulated in a causal connection. There is also a place for the entry of the type of manipulation, if any, used in the experiment: positive manipulation, negative manipulation, non-intervention experiments. Under the approach used, users can log a very brief summary of the techniques used in the manipulation. Besides information about the agent, there is also information about the target. The target is the phenomena that we measure a possible change caused by the agent. The app has a slot to log in the ID of the target. Below this slot, the user can record the effect measured on the target. This effect can be a positive change, more activation of the target, for example, a negative change, for example, when there is a decreased activation measured in the target, or no change in the target. Additionally, the slot next to approach used is for noting key information about the techniques used to measure a change in the target. If any of the key fields are left empty, the app asks users to enter that information. As I mentioned in the first video, we have recently published a book and an article that you may find useful as additional resources to the material in this video series. This brings me to the end of video 4. This video introduced a web app that helps neuroscientists build research maps.